Hello, Ian. I tried to post a message to you yesterday. It didn't stick, so I'm just going to read it out because I put a bit of thought into it, so it's worth at least trying to get the message across. So I said the good thing about using tried and tested clay instead of plasticine is that it is continuously reusable, no matter how dried out it becomes. You can use a food mix or something to homogenize it again with water. They call it slip in the pottery industry. Yeah, when just like thin, it's like thin gravy kind of consistency, and then you get rid of the moisture. Even professional potters just throw everything back into a blunger, just basically a big mixer. They have a lot of odd terms in the pottery industry, as Michael will attest. And the dried and semi-dried clay is soon homogenized. Then the water content is removed. That's simple enough. Uh, I don't have a food mixer, so it was easy for me to just order new clay. That's the other great thing about it. It's dirt cheap, it really is. It's about 15 quid for a massive block, about 8 inches square, 10 inches square, something like that, cubed. Hobbycraft to sell it, but at an extortionate price. There are videos showing you how professional potters ensure the clay is completely homogeneous before they start working with it, because any lack of homogeneousness ruins their work when they're turning a pot. It has to be homogeneous. So that's the material to work with, really, the tried and tested method. Obviously, a potter, no matter how skilled, could not turn a pot using plasticine because it has a weird consistency, doesn't it? It's kind of elastic, isn't it? A bit stretchy, whereas clay appears to have very little elasticity. You could do a test comparison by making a ball with each substance and wrapping it in cling film or whatever to stop it being sticky, and then just see if one of them bounces at all, throw it against a wall or the floor or whatever. I've not tried it, but I'm just guessing that plasticine might have more bounce, whereas I predict that clay would just flatten against the surface you throw it against. That's my guess anyway. I thought I'd better put my money where my mouth is, Ian, on this clay versus plasticine issue. No criticism implied, really. It's just, I think it's an honest mistake to think that that it works the same as clay. But that's a ball I made out of plasticine, well, Play-Doh. And that's a ball I made out of, medium soft clay, similar consistency, and dropped them both on the floor. And you can see that's recorded the damage flat, and that just bounced. Couldn't even tell for certain which part bounced on the floor. I'll show you that again. Hold them both the same height. Clay on the right, plasticine on the left. Can't even see a flat on that, really. Whereas that, flat as a pancake, recorded the energy expended. That took back the energy expended, didn't it, really, I suppose? Something like that, I don't know. I think it's just an honest mistake, that thinking that the two work near enough the same. They don't, do they? Here are just a few examples of clay experiments I've done before. They've gone rock hard now, from about 9 months ago, I suppose. I even did square ones there. You can see that was the height it started out at. That was the height it ended up at B1. Not much difference, is there? And that's the height it ended up with B2. But you can see I couldn't get it to squash exactly. And these were really hard work to make these exactly perfectly straight, so they're exactly the same weights, etc. Compress it all at the, well, let's be fair, let's show the side where you can see some compression. Just a slight reduction in height, and it looks like more like 4 times more there, don't it, because I've allowed sufficient clay for that to happen. Every picture tells a story, doesn't it? There were loads more, but I've destroyed them because, just use the clay again and again, because like I say, it's all reusable. Oh, just one more thing, just to show you the massive amount of clay you get for 15 quid. That's only part of it, delivered. The problem with spring is that it all happens so fast that we end up having to video it at high speed or use some other devious means of trying to determine, what happened in a microsecond. So, and it's just not worth the hassle when we have evidence that clay really is a good measure of the energy expended. So long as we do it the proper way that Will and Gravesend and Emily de Chatelet, whoever else showed us, and even I showed, not the massively flawed way that Mythbusters attempted. It's flawed on a number of counts. One, as someone already pointed out, it cannot possibly give a linear measure of energy expended because the surface area is constantly increasing as it compresses. It gets faster, doesn't it? Therefore, the lengths measured in the two drops are not directly comparable, and it's not even a consistent expansion. It suddenly stops expanding at some point because the clay squeezes out, as I'll mention in point 3 in a second. Two, in Mythbusters' case, they unintentionally, I suppose, spoiled the experiment by over-compressing it on the first run, V1. So it could not possibly show 4 times compression, even if that were possible anyway in an ever-expanding surface, because there was obviously insufficient clay left to compress that amount. So it's fundamentally flawed. I've no idea why anybody gives it any credence whatsoever other than as a piece of entertainment. And to demonstrate, cars crashing. Even that's flawed. But they weren't attempting to measure kinetic energy anyway. They never even mentioned it, not once. All they were trying to do was make a model of a car crashing at 2 different speeds, mainly for entertainment purposes. And it failed in scientific terms because cars are not made of homogeneous material. Everyone's different and not directly comparable with clay, which is homogeneous. So it really is just a piece of entertainment. You should take it as that, not try to read too much into it. Not you personally, Ian, I'm just speaking generally. I don't know how to make this any clearer to people, but just look at the compression. This is before any compression at all, and this is after just V1 compression. Notice that the clay isn't even being compressed evenly. It's bulging out more at the bottom than it is at the top. This is before any compression at all, and this is after just V1 compression. This is the lowest energy, and it's already compressed about half. Well, before any compression, he measured the clay at 2.713, but in another instance, he measures it at 2.6.
Uncompressed length, 2.6.
So there's no consistency, is there?
1.54.
2.6 minus 1.54
equals 1.06 displacement. But even that doesn't mean very much because the clay is clearly getting faster and faster the more it's being compressed, so it gets harder to be compressed. It's not a linear function, is it? Should be exactly the same as
1.28.
2.6 minus 1.288.
That's 1.31. That's a lot more. That's miles off. 1.28, 1.38, 1.48, 1.54. Not even close. Then V2, 50% compressed again.
Post-compression length, 0.777.
Now that was after V2, 0.777. And you heard him say it was 2.6 before compression.
So 2.6 minus 0.777
equals 1.8. So it's displaced 1.8. That's the important bit. How much clay is being displaced, not what's left. Please remember that. They seem to forget that. Volume displacement. Emily du Châtelet, Willem Gravesend, their method, not Gary Guesswork's method. Counting everything backwards if he doesn't like the results forwards. So it's compressed 1.8.
1.5.
Now that was yet another one of his V1 measurements, 1.5, and this is him measuring it at 2.713 before compression, not 2.6 in this instance.
2.713 minus 1.5.
So this is displaced 1.2. So how much more did it displace?
1.8 minus 1.2.
It displaced an extra 0.6. It only displaced half as much again. It didn't displace twice as much, it displaced half as much.
Twice as compressed.
That makes sense, doesn't it?
If you're thick as pig shit.
It does.
No, it doesn't. You're supposed to be measuring the displacement, and it's only displaced half as much again. That's the important thing.
Almost double the compression.
No. It's the displacement which counts. It's not what's left. Otherwise, when I dropped lead balls into the clay, it's like when I drop lead balls into clay. It's like measuring that distance, the remaining clay, instead of the amount of displacement. It's like measuring the amount of clay left instead of the displacement. Nobody in their right mind suggests that when we drop lead balls into clay that we should measure how much clay is left underneath the ball. That's why we measure displacement when we drop lead balls into clay. That doesn't tell you the story. That's the thing that tells the story. The displacement. The volume displacement is what tells the story, not what's left underneath it. If you're going to start measuring how much clay is left After compression, then you have to be a little bit clever about it to determine how much displacement has taken place, because that's the work done. The clay that you've moved, that's the work done. That's not the work done. If I ask you to clear snow off my drive, you don't measure it in terms of how much is left, you measure it in terms of how much you moved. They haven't got a clue what they're doing. So how much more displacement could we have expected from the kinetic energy formula? It should be 4 times V1, shouldn't it? Well, if it was a linear function, which it clearly fucking isn't, the clay's getting fatter and then at some point it squeezes out of the compression zone, so then it doesn't really count in quite the same way. I'm sure it does count to some extent, but how do you determine how much it counts? The whole setup is ridiculous. They've reinvented the wheel and made it a hexagon or something mad. So how much more displacement could we have expected from the kinetic energy formula? It should be 4 times V1, shouldn't it? Well, V1 has been anything between 1 and 1.4. So their results were far from consistent. They didn't even start with the same lengths. They didn't end up with the same lengths in relative terms. If you freeze frame the image of all their examples laid out on the table, they vary massively, but he just holds up the two that suits his story to give a 2-to-1 compression type of story. But that isn't what all the ones laid out on the table look like. They started out the wrong lengths, different lengths, and they've ended up different lengths as well. It's chaotic. It's not a controlled experiment. And it was never meant to be, in fairness. It's only meant as a piece of entertainment. It's chewing gum for the eyes. But some morons think that it's supposed you can interpret this as defeating all the world's greatest scientists who ever lived. The whole thing is just ridiculous and laughable. Well, V1 has been anything between 1 and 1.4. The kinetic energy formula predicts 4 times that V1 displacement. So that's 5.68 inches. Do tell us, parapoly moron, how it's possible for 1.5 inches of clay left, roughly, to compress 5.68 inches. It isn't physically possible, is it, you dickhead? Oh, and I haven't forgotten you just making up a load of numbers that weren't even in the thing until you just admitted that you didn't know where the numbers had come from. I know where they'd come from. You'd pluck them out of thin air to defend Gary. And I have no idea why Mindless Marbles defended you doing that. I have no idea why Mindless Marbles defended you just plucking numbers out of thin air that meant nothing. He thinks you're a civil person, had a nice polite conversation. Well, I think you're a cunt. A cowardly cunt. Just wasting people's time with irrelevant information that you've made up. How you can defend that, I will never know. The kinetic energy formula predicts 4 times that V1 displacement. So that's 5.68 inches. We don't even have half that. The real problem isn't the size of the clay pug. The real problem is that they're putting far too much energy into crushing it right from the get-go. So they are leaving no headroom with which to do the 4 times energy prediction. You can't displace 4.8 amount of clay when you only start out with 2.6 of it in the first place. So you spoil the experiment by not allowing enough clay, or by using too much energy in the sodding first place to permit it to measure kinetic energy proper. All they had to do was make the hammers less dramatic, less big, less huge, make less of a noise, so they only compressed the clay a little bit. Then they would have had plenty of headroom to make a proper kinetic energy measurement. Well, if it was a linear function, that is, but it's not, is it? So that isn't strictly true. You can't expect it to compress 4 times more when it's getting harder and harder and harder to compress it, because it's getting fatter and fatter and fatter, and then at some point it doesn't get any fatter because it's squeezing out the sides. It's a mess, isn't it? They didn't put enough clay in. They had to put a lot more clay in to allow the proper 4 times kinetic energy prediction to manifest. I'm not saying that they rigged the experiment, but if they wanted to rig the experiment, this is what they could have done to convince feeble minds who don't understand the kinetic energy formula, people like Gary and his fans, morons. The simplest solution would have been to make the hammers less heavy, less dramatic. But they wanted it to be dramatic. They wanted it to make a big noise. They wanted to show you them making massive steel hammers weighing half a ton. They were more interested in what it looked like and sounded like.
Satisfying ding, isn't it?
Yeah.
I'm never convinced his friend agrees with him, but he just has to go along with it, doesn't he?
Satisfying ding, isn't it?
Yeah.
His body language says something else, doesn't it?
Satisfying ding, isn't it?
Yeah.
They were more interested in what it looked like and sounded like, that it made a big impression on people, than doing a smaller, accurate experiment. So there's the clay compression when the bottom of that was dropped from the 1 foot mark, 12 inches mark. You could do with seeing that experiment in full, really. That will be quite a long video because it took ages to set it up and get it to drop accurately. I dropped it from 3 inches and 12 inches. It's about a 4 kilogram weight, I seem to remember. And it's kept straight by that bar that it's sellotaped to, so that it doesn't go skew with, and compresses the clay reasonably straight. It's not the most accurate experiment in the world. It's just a rough guide. So I did about a dozen other experiments. I can show you the results of some of those. I destroyed a lot because at the time I was convinced I should be getting 4 times compression, but of course you're not going to get 4 times compression exactly, because it's getting harder and harder to compress it the further it goes down, isn't it? But I got pretty close, 3.5 times, most of them were. But the problem is it would always land awkwardly, and that was the problem I was trying to get over with, similar to what you have managed to get over with quite admirably, Ian, by using those bobbins to keep it straight. I don't know why I didn't think of that, because I'm thick, that's why. but yeah, but this one kept it straight, and so this achieved about 4 times compression. But I don't think it's super accurate because, it was so difficult to hold it at the 3-inch mark and hold it at the 12-inch mark. It's so bloody heavy and cumbersome. Plus, I was having to hold something else to make sure that, to guide it, make sure it hit the target. I was holding a piece of metal. I'll show you the full video, and it'll bore you silly, but the results did come out at 4-1. But I don't think it should have done, really. That's why I don't think it's a super accurate experiment. Perhaps I didn't have the clay as homogenized as it should have been, because it did sort of distort a little bit. So I'm not relying on this as full evidence, which is why I've not published it before. But it was certainly. Then again, MythBusters experiment did similarly, didn't it? Theirs bulged out in awkward shapes as well, didn't it? So if it's fair for them, it should be fair for me, really, shouldn't it? But I don't think it's fair for either of us to use those as good examples. The simple solution is to just go back to the drawing board, go back to Emily du Châtelet, Willem Gravesend experiment, dropping lead balls into clay, measuring the displacement. It comes out super accurate considering it's only bloody clay. Yeah, keep it simple. So there's the clay compression when the bottom of that was dropped from the 1 foot mark, 12 inches mark. And that, my friends, is fair enough, because it's only an entertainment program. It's not an academic science program. Only feeble-minded idiots think it is.
And it's a little bit less than twice as compressed as the Speed 1X hit.
That makes sense, doesn't it?
It does.
Almost double the compression. Told.
These two pieces of clay tell the tale.
Hold on a minute. What about all those other pieces of clay that are completely different thicknesses than you are showing here? You've just picked the two that are twice the thickness of one another. But that isn't the compression anyway. That's the amount of clay that was left after the compression. This is before any compression at all, and this is after just V1 compression. This is the lowest energy, and it's already compressed more than half. Well, before any compression, he measured the clay at 2.713. I presume that's inches. As far as the eye can tell, it's compressed exactly half already. So how can that possibly compress 4 times the amount? It's utterly, utterly ridiculous. That was the starting point. That is half compression. For that to compress the same amount again, it should be paper thin. But look, it's not. It just compresses half as much again. In other words, a quarter of the total distance. Observe. V0, V1, 50% compressed. Then V2, 50% compressed again. Then compress half as much again, not double. In other words, 75% of the total. That's half as much again. It's not double, it's half as much again. These people are a little bit thick. It's compressed half as much again, not double. If it was double, there wouldn't be any clay at all in the middle. No matter how much more energy you put into it,
It could be 1,000 times more energy. You would just end up breaking the machine before it compressed any more clay because there isn't any more clay to compress. There isn't enough clay in it.
What I mean is there isn't enough clay left to measure the proper kinetic energy 4 times displacement. So if they'd wanted to rig the experiment, they could have done this on purpose. I'm not saying they have done that. I don't think they have done that. I just don't think they've considered the kinetic energy formula in doing this experiment. They've kept it as simple as possible for the layman audience, the people who aren't interested in the science, who aren't familiar with the kinetic energy formula predictions, which is most people, I suppose. Well, that's their audience, isn't it? Fair enough. It's just an entertainment program, just to keep us all happy and entertained. Great job in that respect, yeah. But don't treat it as. But please, folks, stop treating it as if it was academic science. It's not. It's so undisciplined. It's ridiculous. It's madness to treat this as an academic scientific endeavor. It's not. It's a piece of junk entertainment. It's chewing gum for the eyes. So it could not possibly show 4 times compression, even if that were possible anyway in an ever-expanding surface, with an ever-expanding surface, because there was obviously insufficient clay left to compress that amount. So it's fundamentally flawed. I've no idea why anybody gives it any credence whatsoever, other than as a piece of entertainment. And to demonstrate, cars crashing. Even that's flawed. Yeah, but they weren't attempting to measure kinetic energy anyway. They never even mentioned it, not once. All they were trying to do was make a model of a car crashing at 2 different speeds, mainly for entertainment purposes. And it failed in scientific terms because cars are not made of homogeneous material. Uh, Everyone's different and not directly comparable with clay, which is homogeneous. So it really is just a piece of entertainment. You should take it as that, not try to read too much into it. Not you personally, Ian, I'm just speaking generally. 3, a lot of the clay in the experiment they did actually escaped from any further compression because it squeezed out sideways. So from that point onwards, the rate of compression would change again, as the surface area would no longer be expanding. From that point on, the surface area was consistent, and then it gets a bit complicated trying to suss out how do you figure how much it should be compressing when it's going sideways instead of being compressed flat within a confined space. The whole thing is a mess. So that makes it a whole lot more complex and subject to argument about how much energy is being expended, with so many flaws in their setup. If they were attempting to measure kinetic energy using the same materials, in other words, clay displacement, I'm certain that they would have simply recreated the classic experiment invented all those years ago, measuring the volume displaced by a ball hitting the clay at 2 different speeds. Anyone who wants to dispute the reliability of that needs to explain why we get the same results whether we drop a 4 mass from height 1 or a 1 mass from 4 times the height. That needs to be explained, why that is supposedly not a legitimate test. Proof as good as that clay is a good measure of energy. Don't care what anybody says. Well, until they give me some evidence as to why that's wrong. Anyway, thank you for listening to me, and sorry if I have to do it this way, but YouTube does suck sometimes. I would press comment, but I've already done that and it won't post again. I'm just wasting my time. How do we end the video? Oh, that button there.